Question number 5. We've been given a quadratic equation which has roots alpha and beta, and alpha squared plus beta squared is equal to 4. From this information we need to find the possible values of k. So firstly, let's find the sum and product of roots. So the sum of the roots of a polynomial that is equal to 0 is given by negative an minus 1 upon an. An minus 1 represents the coefficient of the second largest power, and an represents the coefficient of the largest power. So the sum of the roots, which is alpha plus beta, this will equal negative of negative 2k upon 1. So alpha plus beta, which are the two roots, is equal to positive 2k. Now similarly, we can use the product of roots formula. So the product of the roots of a polynomial that equals 0 is given by negative 1 to the power of n a0 upon an. a0 represents the constant term in the polynomial, an represents the coefficient of the largest power, and n represents the degree of the polynomial. So the product of this quadratic will equal negative 1 to the power of 2 a0, which is k minus 1, upon an, which is just 1. So alpha times beta, which are the two roots, is equal to k minus 1. Now we've been given that alpha squared plus beta squared is equal to 4. So I can also write alpha squared plus beta squared as alpha plus beta whole squared minus 2 times alpha beta. If we expand this, this will give us alpha squared plus beta squared. So let's expand this on the right hand side. So if we expand this, this will be alpha squared plus beta squared plus 2 alpha beta, and then we have minus 2 alpha beta. So this is equal to alpha squared plus beta squared. So we can write this as this. So now from here we can use what we know. So we know alpha plus beta, which is 2k squared minus 2 times alpha beta, and we know alpha times beta is k minus 1. So we can plug in k minus 1 and we can equate this to 4 as told in the question. Now let's expand the bracket. So this will be 4k squared minus 2k plus 2, and I will move this 4 to the left hand side of the equation. So this is negative 4 and this is equal to 0. So 4k squared minus 2k minus 2 is equal to 0. So since 2 is a common factor, I can factor out 2. So we have 2k squared minus k minus 1 is equal to 0. Now to solve this quadratic equation, we can use middle term splitting. So I can write this as 2k squared minus 2k plus k minus 1, and this is equal to 0. Now I can factor out 2k from the first two terms. So inside the bracket we'll be left with k minus 1 plus, and from the last two terms I can factor out 1. So this is k minus 1 inside the bracket, and this is equal to 0. So I can take k minus 1 common from both the expressions. So we have k minus 1 times 2k plus 1. This is equal to 0. Now we can use the null factor law to solve for the values of k. So either k minus 1 can equal 0 or 2k plus 1 can equal 0. So from here we find that k can either equal positive 1 or k can equal negative 1 upon 2. So these are the two possible values of the real number k, and this is the answer to question number 5.